This is passage 3. It's a data passage. We know it's data because all we see are two figures, not experiment 1, experiment 2, study 1, study 2, no students or scientists. So it's a data passage. For our DRC approach, D means data and don't read. We're just going to quickly look at the charts and graphs to better understand what we're looking at. So in this one, it looks like I have a key, and then I have solubility and temperature. Each one of these lines represents a different solution in the key. In figure 2, percent of mass of a solvent and solubility of just sucrose, which I see over here again, and different temperatures. So each line is a different temperature. That's it, 10 to 15 seconds, and then get to the questions. R&R approach the questions, do a quick read through the questions, and then reread breaking it down. We'll reread together. Question number 14. According to figure 1, the solubility of KNO3, which is this dot and dashed line, in water at 50 degrees Celsius is closest to which the following values. It's a little less than 100, so G, 85. Number 15, based on figure 1, approximately how many more grams of sucrose will stay dissolved? So sucrose is this just dotted line, and 100 grams. So 100 grams is, we're just making sure it's the same values throughout at 80 degrees, then at 20 degrees. So 360 at 80 degrees. At 20 degrees, it's about 200 or is 200. So 360 minus 200 is 160. So 160 more grams will dissolve at 80 degrees. So your answer is B. Number 16, which of the following compounds shows the least variation in solubility? So we're looking at solubility in figure 1 because we're also dealing with temperature in figure 1. So as it increases from 0 to 100, which one is the least, has the least variation in solubility? And we see this line is pretty much straight, so no variation in solubility, and that is NaCl, so our answer is H. Number 17, based on figure 1, which of the substances represented in figure 1 is most likely a gas? So there's a little bit of knowledge here, and you may just know that NH3, methane, is a gas. If you don't, you can still eliminate B and C because they don't fit the graph. Look at choice B. NH3, so NH3 is this solid line, okay? The solubility of gases in water decreases as temperature decreases. So as temperature decreases, the solubility increases. So choice B is out, and C is out for the same reason, right? So B and C are both out. So then it becomes a little bit of knowledge though. So in NH3, the solubility of gases in water generally decreases as temperature increases. Decreases as temperature increases. So your answer is A. Number 18, based on figure 2, first time using figure 2, does the solubility of sucrose generally increase as the percent ethanol in the solvent mixture increases? So let's cover this one first. So we see percent of the mass of water in the solvent, not ethanol. So let's think about this. It's going to be tricky. So what's happening is more water means there's less ethanol because we're adding more water. There's less ethanol, right? So we know ethanol is in the solution, but we're adding more water. So as you add more water, the solubility does increase, but that means it is less soluble in ethanol as it is more soluble in water. A little bit tricky to think about that one. So your answer for H and J is no, right? So you can eliminate F and G. Now let's look at temperature. Does the solubility of sucrose generally increase as the temperature increases? So we see temperature over here. So let's just break them down one at a time. Let's start with 25. So that was the lowest line. Then we go from 25 to 40. So that increases, then 40 to 60 increases. So that is a yes. As the temperature increases, the solubility increases. So yes, so our answer is H. Based on figure 1, the maximum number of Ki, so this is the dotted line, in milligrams, not grams, so the knowledge question, how to do unit conversions, that will stay dissolved in 100 grams at 20 degrees Celsius. We can see that, but we really didn't need to because in our answer choices, it's all at 140. ACT is asking, how do you convert grams to milligrams? You can remember the acronym, King Henry died by drinking chocolate milk. We start with the base, which is 140 grams. We're converting it to milligrams. So we're going to move our decimal point to the right, and that will be 140,000 milligrams, which is choice D. So the reporting category for this one is pretty heavy in interpretation of data, which we generally see in data passages. You have one evaluation of model questions, question 16. So reach out if you have any questions. We'll end on our silly joke. Photon checked into a hotel and asked if he needed any help with his luggage. The Photon said, "No, I'm traveling light." Good science joke. Have a good day.